Good afternoon, everyone. So, first of all, we will start with the introduction. That means what would be the need of microservices. So, let me tell you first the basic, what basically microservices is. So, let me start once. Okay, so as we all know, this webinar is all about microservices architectures and how we can implement those architectures. Okay, so first thing we'll get to know if we are talking about microservices, and we can see we heard a lot of talk about like companies are shifting towards from microservices application development. So what would be the need of microservices architectures in current scenario? Okay, so first we will discuss before starting what is microservices is we will need to understand we will try to understand the need of microservices and how we can before microservices or currently we are also using the monolithic application development approach. So basically microservice is a shift from monolithic application development to microservices approach. So let's discuss first what is basically monolithic application development approach and what were the limitations of this particular application development approach so that we need to shift towards microservices. Okay, so let me clear you one thing at very first. Basically, microservice is an architecture. Microservice is not a implementation method, or we can say technology. Microservice is basically an architecture. It gives you the architectural pattern for developing a for developing an application. Based on the microservices architecture, you can develop your application by using any technology, any programming language, any interface. Okay, so let's first why we shifting towards microservices from monolithic application development. So first we need to know what is basically monolithic application development. So here we can see here we are having a scenario where we are having a user and user is interacting with the browser then further interacting with the server, which is the typical scenario when we send a request through the browser. So the browser interact with the HTTP server, and now this server is connected to certain application, and this is basically a monolith application. So here we can see monolith application is a process in which we are having certain things like we are having var, and if we talk about var, that is basically a web archive which contains your jar files. And if we talk about the jar files, what is basically a jar file? It contains various Java classes, JSP, static web pages, dynamic web pages, etc. So here we can see here we are having different component like storage, user interface, catalog services, cart services, search service, order services, etc. That depends upon an application, what type of services our application is basically providing. And this particular web sphere is basically connected to your database, and then as per the functionalities of these services, these services will interact with the database and it will generate the desired output, and then again output is transferred through the server to through browser to the user. So by looking at this particular diagram, we can understand that monolithic application basically what it is in monolithic application, most of the functionality is resided within a single process. Means all the services are resided within a single process. Okay, so that means in a monolithic approach, we are developing our applications where our whole code base resided within a single container, or we can say within a single process. So in current also many organizations are using developing their applications by using this architectural methods, and it is not like that monolithic application development is always bad. Like many organizations are enjoying good results whenever they are using monolithic architectures. Okay, so where the problem will arise. Okay, suppose we are having a monolithic application, and suppose we want to add certain new functionality into the monolithic application. So what will happen in that particular scenario? Because our whole code base is reside within a single container. So what will happen? We need to stop that particular application. Then we will do the necessary changes. Then we will deploy the changes. So what it will do? Monolithic application requires a certain downtime if we want to deploy a new version of the application. And what will be the impact of downtime? If your server is down, of course, so it will impact your time to market. Okay. Next, what can be the scenario with monolithic? It is vital to measure the risk and understand the complexities in development operations, that due to which we are transforming from monolithic applications to microservices architecture. Okay, so what microservice requires? It basically requires organizational level changes. What changes? Such as we need to break our development team into smaller teams, because as the name microservices suggest, we are dividing our services into small, tiny services. So that means we need to break our development team into smaller teams as per the microservice need, and we need special skills in each team who will develop and operate the microservices. So now let's consider a case study where we will understand why we need microservice development approach now. Okay, suppose it is our application. The user is interacting through desktop browser with the application. So this is the interface of the application. Here, the customer service web interface and the customer EJB. So I hope everyone is familiar with these terms. EJB is basically our enterprise Java beans, which are used to provide the business logics, and it provides a runtime environment for web related software. Similarly, customer service dojo, what it will do, the dojo, it is basically a space where all the teams can come together and they can develop their frameworks, they can discuss their technologies, and through which we can add the agility in the development of our application. Okay, so we are, suppose we are developing an application, this is the interface. This application is interacting with the database. Okay, so if we look at this particular architecture, we can understand that this particular architecture contains, we have a relational database schema. There was a single database schema. We were having the products, customer, ordering, etc. features in that particular application. We were having the single EAR file. Basically, it is a jar file extension. We were having the single EJB and JPA persistent. So what is basically JPA persistent? I hope you know Java persistence API, which are used to which contains classes and method to store the vast amount of data into our databases. And we were having the Dojo web application. Now, what is the use of Dojo web application? It will add the agility in the development of your application. It is basically a common space where multiple developers can come and discuss their ideas and methodologies to develop a specific application. Okay, so if we have a broader look, we can see that these enterprise applications, whatever application we are building, often built using these parts. Like we are having a user interface, we are having a database, and we are having a server-side application. Okay, so what is basically monolith? Where we apply the monolith architecture? The server-side application. The server-side application is handling everything like the user request. They are executing the logic. They are retrieving and updating the database. They are generating the result and fetching the result to the user. So basically, the server-side application which we are developing, that application either can be developed by using monolith approach or by using the microservice approach. Okay, so for developing a monolithic application, we always use a layered architecture. And what is a layered architecture? Basically, at the top of the layered architecture, we are having the view of the application, means how it will look to the user. Next, we are having the application model, how we are modeling the particular components of our application. Then we divide the application into specific domains. Then we are having the models for the specific domains, what will be the functionality of each domain, etc. And then we integrate all these domains among themselves and with the database also. Okay, so this is again the scenario. If we are having a monolithic modular architecture, what it will be? It is containing the var, like the web archives, and a single web archive is containing a jar file, and that are placed. They will communicate with through the load balancer to the user, and we are having a cache memory where our current execution data will be stored. Okay, one more problem which we came across when we use the monolithic application, like suppose various softwares, we always use the monolithic software development approach. So whenever there will be certain advancement, whenever the developers feels that we need certain advancement in the software and in the technology, what they will do, they release the higher version of that particular application. So what will happen during the version management of a monolithic application? Suppose we are having an application and it is having three component, basically user interface, database, and logic. Suppose the developer thinks that we need to enhance the user interface of our software. So in that case, what the developer will do, he will enhance the user interface and he will release the next version of that particular application with the enhanced user interface. Now suppose after some time he need to enhance the logic, programming logic of that particular application. So what will happen if we have developed our application using monolith architecture? We will enhance the logic and then we will release, let's say, version 2 of our application again. And suppose next time if we want to do certain changes into the database, then again with the updated database changes we will release the next version. So this is a way if we want to enhance our monolithic application, because whole application is developed inside a single code base. So if we want to enhance a specific part of that particular application, so we need to release the latest version with the updated functionalities. Okay, so by looking so far over the monolithic architecture design pattern, we can say that monolithic application is basically simple to deploy because whole code is reside within a single process. So it is simple to deploy and of course simple to develop. Okay, this is about the scaling. If we want to scale our application, so we know we can scale our application either by using horizontal scaling or by using vertical scaling. So if we do the horizontal scaling, as it is clearly shown in the diagram, if we will do the horizontal scaling, so what will happen? Suppose initially our application was using 2 RAM units, 2 CPU units, one application interface, and it is interacting with the load balancer and services. And suppose the load arises over the application. So through horizontal scaling, what we can do, we can add the with the same capacity more interfaces of the application that will interact with the service as well as with the load balancer. While in the vertical scaling, if we want to vertically scale our application, what we will do within the single unit of our application, means within the same application interface, we will scale the RAM of the application, we can scale the CPU processing unit of the application. So this in these two ways we can scale our application. So that will depend upon the user choice, that will depend upon the developer approach and the development approach, basically ki, either we can do the horizontal scaling of our application or the vertical scaling of the application. Okay, so we have seen the advantages of the monolithic application development. Similarly, it is having certain disadvantages also. And what can be the disadvantages? Like the first one, it can be difficult to understand and modify. Why? Suppose a new developer joined the team and that is working over the monolithic application development, which is already existed. So in that case, for the new person, it is really difficult to understand the whole application, the whole code base, and it is of course difficult to modify also. Continuous deployment, we cannot do continuous deployment in case of the monolithic applications because if we will change something into the code and that change was not correct, so it can lead to the downtime of your whole application. Scaling isn't so much easier with monolithic application development, and there are certain obstacles during the scaling if we are developing a monolithic application. And the most highlighted disadvantage of a monolithic application is it requires a long-term commitment to the technology stack. Why? Suppose my monolithic application was developed 10 years earlier and currently I am using the same application, and suppose I have used the Java technology to develop that particular application. Because my whole application is residing within a single code box, so I need to commit to that specific technology if I have developed that application as a monolithic. So we need to commit to the technology stack because it is not possible to change the whole application. That application is developed into by using suppose Java. It is not possible to frequently move that particular application to some other technology. So it requires long-term commitment with the technology stacks. Okay, so we can conclude after looking all the advantages and disadvantages of monolithic application that these applications are not always bad. There are various successful applications which have been written, and still we are writing applications as monolithic. But there are certain apps in current time, there are certain scenarios where we need faster changes into the applications, and we need to break down the functionalities of the applications. So that is not possible in case of monolithic applications. So that's why we need a microservice application development approach in which we will divide our application into small services. That services are basically known as microservices. So a small change made to a part of the application usually requires the entire application to be rebuilt. Of course, that is the drawback, and scaling of the application requires running multiple copy of the entire application. We need to run multiple copy of the application if we want to scale out our application. Okay, so that's why we need to migrate from monolithic to domain driven design, and how those domain driven design will use your microservice architectures. Okay, so what is basically a domain driven design? A domain driven design is something in which we will divide our application into specific domains. And these domain driven design these are the software engineering approach that aims to draw the context boundaries of application component. Context boundaries means we need to identify that at which particular part of the code this application will not depend on the previous part. So we need to find out the context boundaries, and those context boundaries are specified through the domains. For example, suppose we are having a monolithic application in which we are developing the checkout process. Suppose a user, a particular person doing certain shopping, and he is checking out with the products. So the checkout can be converted into a domain driven design service. How we can divide the checkout process into these three domains. Like in checkout, what we will need the supplier information, we will need the courier information, and we will need the payment information. So these three can be the domain where the whole checkout functionality can be divided into three domains. Okay. After dividing the functionality into domain, the next step would be to create a decoupled and independent component of each domain. Now, suppose we have divided the domain into supplier, carrier, and payment. We need to define the independent components of a specific domain. Let's say we are taking here in the example the payment domain. So what we can do, we need to identify the independent component of payment domain, which can be developed individually or independently. So like here we can see, we can divide the payment domain if we are having an item, the calculation of fee of that particular item. The promotion code, if certain promotion code are applied over the item for that data retrieval, the invoice generation of that particular item, the VAT data of that particular item. So these things we can handle independently. We can calculate the fees independently. We can find out the VAT data independently. We can retrieve the promotion code independently. We can generate the invoice independently. Okay, so at this particular stage, the logical microservice representation of monolithic application is becoming clearer. How we can move from a monolithic application development approach to microservice representational approach. So now the next question would be where to start refactoring, or how we can refactor. So basically, the two approaches can be used for refactoring your monolithic application as a microservice. And these two popular approaches are Big Bang and phase-based refactoring. So these two are the two different approaches. Either you can use Big Bang approach or you can use phase-based approach. So if you will use the Big Bang approach, so it requires developing the architecture independent in isolation of the existing system. So that means your code will not be tested before deploying. जब तक till when you will not develop the full code, it will not be tested. So we will develop the microservice independently and in isolation if we will use the big bang approach. And after that, when all the microservices will be developed, then these microservices will tested and deployed simultaneously. The second approach is phase-based approach. So phase-based approach is just the reverse of Big Bang approach. We will do in this particular approach, independent part of the applications can be revamped into small, going through the phases until the application is replaced with microservice. That means what we can do, we can have certain code base which is running as it is like the previous approach. Now we will take a small part of the application, we will try to develop a microservice for that particular part, and we will test the microservice step by step, and when we will develop the complete microservice, we will replace that particular part with the existing monolithic part. So the any of the approach can be used. So big bang approach can be useful if we will developing a new application and we want to start developing our application from the starting on the base of the microservice architecture. And phase based approach can be applied if we want to convert our monolithic application into a microservice one. So what we can do, we can take a specific part of the application and we will try to develop a microservice for that particular code base. So like this can be a prototype model if we are developing a microservice approach, not this one. Okay, so let's have a look over the first one. What's happening here? Suppose we want to develop a car. So what we are doing here, we have just developed a wheel. So this wheel is not useful. Next step, we have developed four wheels. So these are also not useful because these wheels are not fulfilling the objective of a moving object. Next, we have developed the body over the wheel, but it is also not fulfilling the objective. Our objective is fulfilled at the fourth phase where we have developed the whole car. So instead of using this particular approach, what approach we can use? We can use the below mentioned approach, where what we can do, we are generating a prototype of a moving object. So here what we have generated, two wheels and there is a body which can move. So it is not like the actual product, but it can give you certain clarifications that we need to develop a product which need to move. So we will enhance this product. In the second phase, we have added a handle. In the third phase, we have added a space for sitting. In the next phase, we have enhanced the model to more, and in the last phase we have developed the actual product. So this approach should be used for developing a microservice application. That means we need not to develop our application like this, that it will only be completed at the end of the last phase. We need to develop our application like this, so that after each phase you can get a more clearer idea that what enhancement you need to do in your application. Okay, so microservice, as I told you in the starting, do not get confused with it. It is not a technology, it is basically an architectural style. So microservice is an architecture style in which large complex applications are composed into one or more smaller services, and these services can be deployed independently, and these services should be loosely coupled. Loosely coupled means, of course, these services are developed for a single application, so of course these services should be dependent, they will share certain data, but these services should be loosely coupled. Each of these microservices focuses on completing one task only, and they do that task with most of expertise, and they do not worry about the other task of the application. Okay, so it is just a small example. If we are using a application development approach using microservices, suppose we are having a service for flight booking. So how flight booking can be divided into small microservices, like flight booking can be divided into these different microservices. We can have a microservice which will manage the rewards. We can have a microservice which will look at the timetable of the flights. We can have a different microservice which will calculate the fare for the journey. We can have a microservice which will update to the customer, whether the ticket is booked for that particular customer or not. We can have a different microservice for adjusting the inventory, and we can have a different microservice for allocating seats. So for instead of developing the whole application for flight booking as one, we can develop the application in these different microservices. Then we will connect these microservices through APIs, so that these microservices will communicate with each other for the desired data. Like here we can see, if we want to update to the customer whether the flight is booked for that particular customer or not, so for that what we need the information from allocate seat service, we need the information from calculate fare service, we need the information from timetable lookup, and if there were certain rewards for booking the flight, so we need information from this one, and as well as in inventory, then we can update to the customer. So of course there should be an API or interfaces between these microservices, so that these microservices can communicate with each other. Okay, the most highlighted disadvantage of microservices is that if we are having different microservices, each microservices can be developed in any programming language. It is not the necessity if we are developing one microservices in Java, then second can be developed in Python, etc., and so on. They can communicate with each other by using APIs. Okay, so we need to add the APIs between two different microservices. Microservices also have a bounded context. Bounded context, as I told you earlier, that means a specific boundary, that a specific microservice will only deal with these things, whatever you have specified in that microservice. It will not look out of the boundary. They do not need to know anything about underlying implementation or architecture of other microservices. Okay, so if we will compare these two, we can say if we talk about the code, in monolithic we are having a single code base, and in microservice we are having multiple code base. If we talk about the understandability, monolithic application is often confused and hard to understand, while microservices are much better in readability. If we talk about the deployment, the monolithic deployments are complex, while the microservice deployments are simple. If we talk about the languages, here the entire application should be developed in one programming language, while microservices can be developed in different programming language. If we talk about the scaling, so of course it will require to down the whole application for scaling, while in case of microservices, we can scale the entire application without bottlenecking the whole. So these are certain key benefits if we will use the microservice development approach. Components are loosely coupled, microservices are language neutral, easily scalable, and ease of deployment. Okay, so by looking over the architectural design, we can see what is the future of microservices. So nowadays there is much more hype about microservices. So the modern system architecture idea can provision small services with full life cycle control, so that this architectural development approach will stay here for a long time. That means in future there will be more application which will be developed using microservices architectures instead of monolithic architecture. Developer deploy only the services that are needed as part of a rollout. Rollout means suppose a specific component have failed. So if we have developed our application using microservices, so in that case, in failure case, what we need to do, we will only deploy the specific part which was failed, not the whole application again. However, as with gaining adaptation of new technology, there are few broad classes of problem that microservices also cannot solve, and that problems require special attention. What are those classes? Like if the user requirements were incorrect. If the user have given you incorrect requirement, whether you will use microservice approach or you will use monolith approach, that means you need to start developing from starting. Significant operation resource use, how many resources you need to use. Substantial DevOps skills required. Of course, for developing application through microservices, we need the substantial DevOps skills. That means agility. We need more agility in development of our application. And of course, we need to implement implicit interfaces for the connection of different microservices. So in future there are right now there are not so many standards for describing microservices, but in future we expect to see standards for describing microservices. Currently what we are using to create microservices, like JSON file formats or XML over the HTTP to provide REST APIs. Okay, so now uh, Mr. Joni Kumar will proceed with the technology development methods if we want to develop a microservice application, suppose. So what methods we will use? So Mr. Joni will proceed with Node.js architectural method for developing microservices application.
So, thank you, Nidhi, for giving us a very good and valuable information and a good examples for describing the microservices. Okay, now it is over to Mr. John Kumar.
Yes.
Thank you, sir. Good afternoon, all of you. I'm here for discuss about introduction of Node.js. Sometimes we call Node.js as a server-side JavaScript. As you know that the JavaScript is basically is the part of web designing in terms of we can say that the JavaScript is the part of web designing in which we decide uh, how the web components will behave, right? In case of web designing, if we check the part of JavaScript. JavaScript says that the behavior of the components, right? And it is only the client side language, right? For validation purpose only. But the Node.js is the advanced version of JavaScript, or we can say that the server side JavaScript. It means now this time JavaScript will support at the server side also, right? First of all, we discuss some background about the Java Node.js. Here is the V8 is the open source JavaScript engine developed by the Google, and it's written in C++ and is used for the Google Chrome browser. Node.js runs on the V8. V8, we know it is the product of Google, right? And the main developer of the Node.js is Ryan Dahl. He's developed in 2009. Node.js is open source very well. It also good for the Windows server, right? If we talk about the introduction of Node.js, we can simply say that Node.js is a server-side JavaScript. It means now the JavaScript will help you. That before, in starting time, the JavaScript is only for the client-side language, and its main purpose is for the client-side validation only, right? Now, in the form of Node.js, JavaScript support us at for the server side. It is uh, it is a command line tool. It means basically जो Node.js is has a interface based on the command line. Event driven non-blocking input output model, which makes it lightweight. Non-blocking input output model says that if there is a condition for input and output, then the processing will not stop, and the connection will wait to terminate the input output, and then next compute the same logic after getting the input output control. It makes callback functionality. uh, Callback functionality says that here we can call function within other function, or we can say that the output of a function will provide to input of other function for completed the complete functionality. This will discuss with the help of a program in the last of session. Programs for Node.js are written in JavaScript, but not in the same JavaScript as we are used to. Some of the students have the knowledge of JavaScript, but Node.js is not the just like the code that you are used in JavaScript, right? Like you have used the DOM model for development in the JavaScript, but in case of Node.js, we have no DOM model, right? Uh, Here the notation are something different. Here, in case of Node.js, everything is run with a single thread. Here is the processing model of, or we can say the life cycle of the Node.js. In case of other web development platform or other applications, here we can see that the at the server side here is the Node server, right? But in case of other technologies, at the client side we have something other platform, and the server side at the other platform, right? In case of in mostly cases at the client side we use HTML and CSS and JavaScript, and the server side it may be Java, it may be PHP, it may be some other languages, right? But in case of Node.js, JavaScript at the both end. Client side we can also code in JavaScript, and server side also we can code with JavaScript, right? So we can say that in the case of Node.js, the client and server both have the same language. So in this process, we create a request from the browser with the help of HTML, CSS, right? With the logic in the coded in the form of JavaScript, that JavaScript request the REST web services, and the REST web services again processing the logic and the process the request and generate the response for the particular request and return in the form of JSON. JSON again is the format we can store the data, or we can traverse the data in the form of JSON. JSON, we can say that it is the light version of the XML. You know very well the what is the XML, right? Features of Node.js. Node.js is a server-side programming, as we discussed earlier, a framework that uses JavaScript as its programming language, right? Node.js again, we can say that is basically dependent on the syntax of JavaScript, right? And having some other features also. Node.js is built with a heavy emphasis on the concurrent programming with a lightweight language, right? Concurrent programming says that in case of Node.js, as we know that JavaScript is a lightweight language, then it can emphasize on concurrent processes. It can execute multiple processes at a time in with a overlap time. Next one is Node.js also comes with built-in support for package management. Like we know very well that the power of a language we can checked by its supported library, right? So then in case of Node.js, we have inbuilt support for package management, right? Like using the NPM, Package Manager. In case of Node.js, we have great library support in the form of packages. Now we discuss how we start with Node.js. First, we have to install Node.js in our system. Then we have to use the editor for writing. Editor may be like as you can any editor like Notepad, Notepad++, text editor, any text editor as you want. When you done open command prompt or terminal, you can type this. You can like this like other languages. You have to compile first of all compile the source code and then you have to run. But in case of Node.js, you have only you can directly run the JavaScript file. As you know that JavaScript is the language interpreted language, right? Here we have no need to first is compile it and then run it. We can directly run it. Here we have some code in form of JavaScript that we can run in our practical session at the end of this session. First of all, we have some follow some steps for run our basic first project in case of Node.js. So first of all, we have to install uh, Express.js globally. So you have to first of all you have to create a folder where you want to execute your Node.js applications. Second step, you have to install G-Express. So you have to type command install dash G-Express. After that, you have you find one folder Express in this directory. This will confirm that your Node.js is installed successfully. In next step, you have to import generator package. You have to install Express generator for creating the directory for implementation of the Node.js. This one is the directory. When you want to create a project, you just write the command express space name of the project like express my app. After pressing enter, then the following directory will be created for the development of Node.js, right? So basically, my app is the project, and there are a lot of directory we have default created on the execution of this command. Like there are lots of folders like JavaScript folders, image folders, style sheet folders, right? For supporting documents, we have different directories here. After that, we have to enter in the folder of my application, name as my app, and here we have installed the dependencies of projects we have to required using command npm install. This command is very depends on the operating system. In case of Windows, you can use the upper version, and in case of Linux or Mac OS, you have to use lower version. After executing, you will get the output like this window. After that, in the last line, you will see that my app server, my app is the name of the project, and listening on the port 300. It means your application is executing on the port number 3000, and you can, if you enter the URL localhost colon 3000, then you will get the output of your application, right? After that, we have to practice some logic part, or we can perform some practical also. Either you have to install the complete platform, or you can directly use the online platforms for performing your project implementations. Here I am using the rapid.it online. It's a online platform, right? Then this is the your index.js file. If you have something, some information about the web development, that then you have the knowledge that the first file of your project must be named as indexed, right? Likewise, we have first created a file index.js. Here we have to we okay, yeah. The first statement says that here is the variable. Syntax is so simple, like as you know, as you read in JavaScript, right? Same syntax is follow here. So we have to create first variable HTTP, and we have to use require method. Require method is basically used to use predefined or inbuilt modules that already defined in supported library for Node.js. Here we have to use HTTP module. It is a inbuilt module for creating HTTP request. Then with the help of HTTP variable, we can
Hello,
execute its method
uh,
create server.
hello, Johnny sir. Hello.
Yes, sir.
Are you
Yes,
showing
sir.
the demonstration on some editor? Are you showing the demonstration on some editor, or this? Because I think the PPT is open. Are you showing some demonstration on some editor or not right now?
Yes, sir. Yes, sir. Some editor.
Okay, but actually, no, I think the PPT screen is visible to all of us.
Okay, sir. I will share complete window.
Okay.
Sir, is it visible?
Yeah, now it is fine. Now it is visible.
Okay, okay. Thank you, sir. Okay. Here, some predefined module is HTTP. It is the module for creative HTTP request, and we have to perform some type of request for data available on the server, or service available on the server. Here we are creating the request of HTTP type with the help of this method create server. Create server has an argument like this. This is the term we have discussed in the introduction, like callback functionality. Callback functionality says that this function firstly execute and returns some output. That output will be work as an input for the create server. And after that, this function, this method dot listen 800. Right. This is the example of callback functionality. Okay, a create function has a argument, some anonymous function. Anonymous function says means that it has no name, directly execute functions without name, right? This function has two parameters, request and response. In case of client and server, you need two parameters in every platform like Java, JSP, and PHP. Request and response are two parameters, or two, we can say that two variables are required for creating the connection to the server. Request is for creating the request, and response uh, is for the getting the response from the server. In this code, first we access the response dot write head. Write head method is basically you what are the content you are typing. Okay. First parameter is the 200. 200 is a parameter that shows that is everything is okay and function will execute completely. Second one is the type of content. What are you writing? Is the here is the content type is the text or HTML. It means right hand says that the everything is okay and the writing content is the in the form of text or HTML. Rest.end is the method for completing the task after printing this string part. When we execute this, this will be the output of your code. Right, this is the hello world. Basically, the Node.js is dependent on the modules. There are lots of inbuilt modules, and we can also develop our custom modules also, right? We have some codes. Uh, yes, yes. First, we use the inbuilt module like HTTP. HTTP we use with the help of require method. Here we are creating user-defined module, right? In this module, we are exporting my date time. With the help of function, this function will return the date and time. As you know, in case of JavaScript, the date is a method that returns the date, right? This module, we are including our code with the help of again require function, right? In this module, we are add two modules. First one is the HTTP. HTTP is the inbuilt module, and second module is the my first module. This is the user defined module. Remaining working are same. First we have to create the connection with the server, with the create server. Next we have to again tell the status of the method and the content type we have to write. And next we have to access, we have to access the working of the module, my first module. Then we are passing here some string. The date and time are currently this class. This is the syntax of JavaScript, and this is the dt dot my date time. Okay, dt is the variable name of my first module, and my date time is the uh, function that is defined in the user defined module, my first module. Now we are executing this. For executing this, yes, we have to change here. The file name is include underscore module.js. It will take time, but we can directly execute this by the copying in the index file, because if we run directly, then defaultly index file will be execute. Okay, yeah, this. Yes, this is the output of this code. That date and time are current. This one is the string that we are directly printing, and the next is the data written by the module, user defined modules, right? With the help of Node.js, we can also implement the file system at the server side. For that, we we have some code for writing some text to any file that is present on the server. Like here is the inbuilt module is FS. FS stands for file system. Again, file system has the function write file. In this file, first parameter is the name of the file. Second one is the content that we have to write in the file. Then the function. Anonymous function have the parameter error, right? If any error, then it will return that error, right? After that, console.log will print the saved. Again, we will copy this code and paste at the index file and then run. In log file, you can see the saved is print. It means the function execute correctly, and we have to check file F3. Yes, this one is the F3. Yes, F3 has the content, hello content. We can change the content. Again run. Yes. Right. With the node of Node.js, we can create any file also. This is the code for creating. This is the writing the file. This is for the creating the new file. And if we want to read some file, then the code will be this. Again, there are two modules. First one the HTTP, second one is the file system. The remaining working is the same, but the method will change. The method is the read file of the file system. Again, the file name and the parameter function. Now function have two parameters. First one is the error, second one is the data. Data is the content written in the file, and that data will pass in the right method for the response. For running this, we have to copy this code and paste in the index file, then run. Yes. F1 is the HTML file and the code is this. HTML part is this, right? We can also use some other files like f2.txt, right? Yes. The content of f2 is hello, how are you, right? Now for reading some file, we have already done. Okay, yeah. Likewise, there are lots of support Node.js has provided. We can create some other request also like FTP request or TCP request also we can create with the help of Node.js. Now, thanking all of you. Now I hand it over to Ravasa.
Thank you, Johnny sir, for giving a simple and informative example so that we can understand how we write a script using Node.js. Now I think who will proceed, Vinesh sir or Pratik sir?
Sir, I will proceed, sir.
Okay. So now I welcome Dr. Pratik Srivastava to carry forward the session. Over to you, Pratik sir.
Okay. Thank you, Ravis sir. Thank you so much. Thank you, Johnny sir, for providing me an opportunity and conducting the remaining part of the session. So I'm going to cover the topic Docker. So let me share my presentation. So फर्स्ट ऑफ ऑल माइक्रो सर्विस में डॉकर का क्या इंपॉर्टेंट रोल होता है और क्यों हम इसे यूज करते हैं वो हम इसमें पूरा कवर अप करेंगे. So before giving the description on the Docker, let me consider some points and some issues which really exist in the real-time scenario in the real-time development. So first question is developing an application requires starting several of microservices in one machine. जैसे कि हमने देखा था कि microservice में हम particularly जो monolithic architecture है उसमें हम particular जितने भी processing या services होती हैं हम उनको distribute करते हैं और वो छोटी छोटी services हमारी कहीं ना कहीं microservice होती हैं, right? So if we are starting 5 of this service, you require 5 virtual machines on that machine. So इधर basically इसका मतलब ये है कि जब हम particularly कोई host machine में या particularly हम कोई अपनी web service को या कोई web application को micro service में distribute करते हैं तो वो सारी web service को जब हम particularly host machine में जब embedded करेंगे तो वो सारी web services वो सारी जो micro services है कहीं ना कहीं virtual machine का यूज करती हैं. virtual machine जैसे कि हम देखते हैं VMware है जिसका हम यूज करते हैं. virtual machine virtualization टेक्नोलॉजी का एक एग्जांपल है जिसमें हम होस्ट मशीन में ही गेस्ट ऑपरेटिंग सिस्टम जो है इंस्टॉल कर सकते हैं एज अ वर्चुअल मशीन की तरह. मतलब फॉर एग्जांपल अगर मैं विंडोज ऑपरेटिंग सिस्टम एक होस्ट ऑपरेटिंग सिस्टम है और मैं उसमें अगर पर्टिकुलरली लाइनक्स ऑपरेटिंग सिस्टम को अगर यूज करना चाहता हूं तो उसके लिए मैं वर्चुअल मशीन को उसमें इंस्टॉल करूंगा. वर्चुअल मशीन का सॉफ्टवेयर है दैट वाज इन VMware. सिमिलरली ऑरेकल का वर्चुअल बॉक्स होता है उसका यूज करके हम अपनी वर्चुअल मशीन उसमें क्रिएट कर सकते हैं. वर्चुअल मशीन जब हम क्रिएट करते हैं तो वो हमारे ही सिस्टम के रिसोर्स को कहीं ना कहीं ऑक्यूपाई करता है. फॉर एग्जांपल जब हम पर्टिकुलरली अपने होस्ट मशीन में कि विंडोज में अगर कोई वर्चुअल मशीन क्रिएट करते हैं 2 वर्चुअल मशीन क्रिएट करते हैं तो दोनों वर्चुअल मशीन कहीं ना कहीं हमारी रैम हमारी सेकेंडरी मेमोरी एज वेल एज हमारे CPU साइकिल्स को कहीं ना कहीं अलॉट कर लेती है, अपने लिए रिजर्व कर लेती है, राइट। तो जब हम पर्टिकुलरली ऐसी माइक्रो सर्विस को जब इंप्लीमेंट करते हैं तो इंप्लीमेंट करते समय हम कहीं ना कहीं वर्चुअल मशीन का यूज कर सकते हैं। लेकिन वर्चुअल मशीन का सबसे बड़ा इशू ये होता है कि वर्चुअल मशीन में जब हम पर्टिकुलरली इंस्टॉल करते हैं या वर्चुअल मशीन जब क्रिएट करते हैं तो जितने भी सिस्टम रिसोर्सेस होते हैं उसको हम अपनी तरफ से रिजर्व कर लेते हैं, भले हम उसको फुल यूटिलाइज नहीं करें। फॉर एग्जाम्पल अगर हम डेटा स्ट्रक्चर में अगर हम बात करें तो हम अरे भी यूज करते हैं, लिंक लिस्ट भी यूज करते हैं, लेकिन लिंक लिस्ट को यूज करने का कारण ये होता है क्योंकि अरे जो है वो कहीं ना कहीं स्पेस का एफिशिएंटली यूटिलाइजेशन नहीं करता है। जब हम अरे क्रिएट करते हैं तो हमको उसका साइज पहले ही क्रिएट करना पड़ता है। फॉर एग्जाम्पल अगर मैंने 100 ब्लॉक्स की अगर अरे बनाई है, उसमें अगर मैं 10 को यूज कर रहा हूँ, 10 ब्लॉक को, तो 90 ब्लॉक्स जो होंगे मेरे लिए वेस्ट जाएंगे, राइट। तो सेम एज इट इज वर्चुअल मशीन में सोचिए कि वर्चुअल मशीन में भी कहीं ना कहीं हम पर्टिकुलरली रिसोर्स को अपने लिए रिजर्व कर लेते हैं, भले हम उसको फुली यूटिलाइज नहीं करें। तो ऐसी कंडीशन में अगर हम सारी माइक्रो सर्विस को अगर अलग अलग वर्चुअल मशीन में हम इंस्टॉल करेंगे, वर्चुअल मशीन में क्रिएट करेंगे और हम उनको अगर यूज करना चाहेंगे तो वो सारे यूज तो हो सकते हैं लेकिन वो सारे रिसोर्स को एफिशिएंटली यूटिलाइज नहीं करेंगे। तो ये सबसे बड़ा इशू था जब हम माइक्रो सर्विस को इंप्लीमेंट करते हैं। सो सेकेंडरी इशू क्या है जिसके कारण से डॉकर को अडॉप्ट किया गया? दूसरा प्रॉब्लम ये है, जैसे कि हम सब जानते हैं रियल वर्ल्ड में कहीं ना कहीं हम इंडस्ट्रीज के बारे में देखें तो इंडस्ट्रीज कहीं ना कहीं हमारे लिए सॉफ्टवेयर क्रिएट करती है, राइट। जैसे कि आईआरसीटीसी का सॉफ्टवेयर होता है, जो ऑनलाइन बैंकिंग का सॉफ्टवेयर, कहीं ना कहीं सारी वेब एप्लीकेशंस क्रिएट की जाती है और ये सारी वेब एप्लीकेशंस कहीं ना कहीं ग्लोबल डेवलपमेंट सेंटर जिसको हम जीडीसी कहते हैं उसमें क्रिएट होती है। तो जब कोई डेवलपर ऐसी एप्लीकेशंस को बनाता है तो वो अपने सिस्टम पर पहले उसको रन करता है, अपने एनवायरनमेंट में, अपने कंप्यूटिंग एनवायरनमेंट में उसको इंप्लीमेंट करके रन करता है। जब उसे रन करता है तो वहां पर उसे आउटपुट सही मिलता है, लेकिन जब वही कोड जब पर्टिकुलरली किसी प्रोडक्शन में किसी क्लाइंट को दे दिया जाता है तो वहां पर वो कोड रन नहीं करता है। तो एक दूसरा फ्रस्ट्रेशन लेवल होता है। सो ये एक सेकेंडरी प्रॉब्लम थी जिस कारण से कहीं ना कहीं डॉकर को अडॉप्ट किया गया है। सो डॉकर को माइक्रो सर्विस में इंप्लीमेंट करने के लिए सबसे पहला रीजन तो ये था कि वर्चुअल मशीन जो है हमारे सिस्टम रिसोर्स को एफिशिएंटली यूटिलाइज नहीं कर पाती, दैट मींस हम इसको यूज नहीं कर सकते। और दूसरा, जब हम पर्टिकुलरली कोई कोडिंग करते हैं जीडीसी सेंटर में, जब ग्लोबल डेवलपमेंट सेंटर में, और जब हम उसी कोड को हम किसी क्लाइंट को देते हैं और जब उस क्लाइंट उसको रन करता है तो वहां पर उसे वो आउटपुट नहीं मिल पाता है, राइट। तो ये दो ऐसी प्रॉब्लम्स थी जिस कारण से माइक्रो सर्विस को इंप्लीमेंट करने के लिए डॉकर का ही यूज किया गया। नाउ वी विल सी व्हाट इज डॉकर, हाउ डॉकर सॉल्व दिस प्रॉब्लम। सॉरी। सो डॉकर इज अ लाइट वेट ओपन सिक्योर प्लेटफॉर्म। लाइट वेटेड है, ओपन है, सिक्योर है। सेकंड, सिंप्लीफाइंग बिल्डिंग शिपिंग रनिंग एप्स, राइट। जितने भी एप्लीकेशंस हैं अगर हम डॉकर का यूज करते हैं तो डॉकर का यूज करके हम इजीली उसको बिल्ड कर सकते हैं, इजीली हम उसे ट्रांसफर कर सकते हैं, इजीली हम उसे रन कर सकते हैं। इसका रीजन क्यों है वो हम आगे की स्लाइड्स में देखेंगे। रन नेटिवली ऑन लाइनेक्स ऑन विंडोज सर्वर। अगर देखा जाए तो डॉकर जो है बेसिकली लाइनेक्स और विंडोज सर्वर पे इजीली रन करता है, लेकिन अगर हम चाहते हैं कि डॉकर को अपने विंडोज पे, जैसे हमारे पास हम लोग अपने सिस्टम पे विंडोज यूज करते हैं तो या तो वो प्रोफेशनल होता है, या तो होम होता है, या तो अल्टीमेट होता है। तो अगर आपके पास होम है, प्रोफेशनल है, तो ऐसे टाइम पे विंडोज पे अगर आपको डॉकर को रन करना है तो आपको वर्चुअल मशीन को इंस्टॉल करना पड़ेगा। वर्चुअल मशीन इंस्टॉल करने के लिए आप VMware का यूज कर सकते हैं या वर्चुअल बॉक्स का भी यूज कर सकते हैं। पांचवा पॉइंट है, डॉकर इज बेसिकली रिलाइज ऑन द इमेजेस एंड कंटेनर्स। अब ये इमेजेस और कंटेनर्स क्या होते हैं, ये दोनों पॉइंट्स हम लोग नेक्स्ट स्लाइड में कवर करेंगे। व्हाट इज इमेज एंड व्हाई वी यूज द कंटेनर। सो डॉकर ऑर्गेनाइजेशन का नाम है। अगर हम कहते हैं डॉकर, तो डॉकर एक टेक्नोलॉजी नहीं है, डॉकर एक ऑर्गेनाइजेशन का नाम है। जैसे हम कहते हैं गूगल, गूगल की जीमेल सर्विस होती है, याहू, याहू की याहू ईमेल सर्विस होती है। सेम डॉकर की भी सर्विस है कंटेनर जिसका हम यूज करते हैं। सो वर्चुअल मशीन, जैसे वर्चुअल मशीन और जो कोडिंग की प्रॉब्लम जैसे हमने दो देखी थी, उसका सॉल्यूशन डॉकर ऑर्गेनाइजेशन ने बहुत एफिशिएंटली प्रोवाइड करा बाय यूजिंग द इमेजेस एंड कंटेनर। Now we will see what is image and what is container. Image is basically the coding part which is designed by the developer. जब हम particularly अगर हम बात करते हैं डॉकर में तो हम इमेज की भी बात करते हैं और कंटेनर की बात करते हैं। अगर हम इमेज को अगर रिप्रेजेंट करना चाहिए, अंडरस्टैंड करना चाहिए, तो सोचिए एक एग्जांपल से कि जब हम पर्टिकुलरली किसी क्रॉप के बारे में बात करें, किसी बीज के बारे में बात करें, तो समझिए वो बीज एक इमेज की तरह है। लेकिन जब उसी बीज को हम जमीन पे बोते हैं, उसे खाद देते हैं, उसे पानी देते हैं, तो जब वो एक पेड़ का रूप ले लेता है तो वो हमारा एक कंटेनर होता है। तो डॉकर में हम पर्टिकुलरली इमेज क्रिएट करते हैं और जब उसको हमको रियली रन करना होता है तो हमें उसका कंटेनर बनाना पड़ता है। मतलब कंटेनर इज रन टाइम एंड डॉकर इज योर कोडिंग पार्ट, राइट। नाउ नेक्स्ट वी विल सी व्हाट इज कंटेनर। जैसे मैंने अभी आपको बताया कि डॉकर एक टेक्नोलॉजी है जिसमें पर्टिकुलरली हम एप्स को इजीली बना सकते हैं, इजीली बिल्ड कर सकते हैं, इजीली शिप कर सकते हैं, इजीली रन कर सकते हैं और स्पेसिफिकली इसको लाइनेक्स और विंडोज सर्वर पे रन करते हैं। लेकिन ये कैसे होता है, उसके लिए हम कंटेनर्स का यूज करते हैं। जैसे कि अभी आप यहाँ पर डायग्राम देख रहे होंगे कि हमारे पास यहाँ पर एक सिस्टम है, सिस्टम पर कर्नल होता है और कर्नल के ऊपर हमने कंटेनर बनाया है। कंटेनर बेसिकली होता क्या है, कंटेनर जो होता है वो आपके ऐप और उसकी सपोर्टेड लाइब्रेरीज को कंटेन करता है। मेक इट क्लियर। जैसे सपोज करिए कि मुझे, जैसे कि हमने सबसे पहला सेकंड नंबर का जो प्रॉब्लम देखा था यहाँ पर, कि हम जब कोडिंग करते हैं तो हमारे जो कंपनी का एनवायरनमेंट होता है, कंप्यूटिंग एनवायरनमेंट होता है, वहां पर वो कोड इजीली रन कर जाता है, लेकिन जब हम उसे किसी क्लाइंट के प्रोडक्शन में दे देते हैं या क्लाइंट साइड पे दे देते हैं तो वो रन नहीं करता। दैट मीन्स वहां पर प्रॉब्लम क्या होती होगी कि उसका कंप्यूटिंग एनवायरनमेंट जो होता है वो अपडेटेड नहीं होता है। दैट मीन्स दैट्स व्हाई वो आपका जो कोड आप जो प्रोवाइड कर रहे हो वो रन नहीं करता। तो इसका सॉल्यूशन डॉकर ने कैसे निकाला? डॉकर ने बेसिकली क्या करा, कंटेनर आपको दे दिया, और डॉकर ने क्या करा, कंटेनर के अंदर आपका ऐप और उससे सपोर्टेड लाइब्रेरीज आपको दे दी, और उनको पूरा एक बाइंड अप करके एक इमेज के रूप में आपको दे दी। जब आप उसे यूज करना चाहोगे तो कंटेनर बना के उसको रन करके यूज कर लोगे। मतलब बेसिकली किया क्या है कि वर्चुअल मशीन की जगह अब हम डॉकर का इसलिए यूज करें क्योंकि डॉकर ने हमको क्या दिया है, कंटेनर। कंटेनर के अंदर बेसिकली है क्या, तो कंटेनर के अंदर जो है आपका ऐप जिसे आप यूज करना चाहते हो और उसकी सपोर्टेड लाइब्रेरीज, इन दोनों को बाइंड अप करके ही एक पूरा कंटेनर बना करके इमेज के रूप में आपको दे दिया। जब आप उसे इमेज को रन करोगे तो आपका एक कंटेनर आपके सिस्टम में क्रिएट होगा और उसे आप इजीली यूज कर पाओगे। जैसे कि यहाँ पर आपको अलग अलग तरीके के 3 कंटेनर दिखाई दे रहे हैं। देखिए कि पहला कंटेनर है जिसमें टॉमकेट सर्वर की भी हमको जरूरत है, जावा की भी जरूरत है और डेबियन ऑपरेटिंग सिस्टम की भी जरूरत है, राइट। तो ये कंटेनर ऐसा है जिसमें पर्टिकुलरली जो ऐप रन करेगा उससे रिलेटेड सपोर्ट लाइब्रेरी इसमें दे दी गई है। सेकंड आप देख रहे होंगे कंटेनर जिसमें एसक्यूएल सर्वर है, डॉटनेट है, यूवेंटो ऑपरेटिंग सिस्टम है। मतलब बेसिकली इस कंटेनर के अंदर डॉटनेट सर्वर को यूज करने के लिए कोई ना कोई ऐप होगा, डॉटनेट एनवायरनमेंट भी होगा, एसक्यूएल सर्वर डेटाबेस भी होगा, यूवेंटो ऑपरेटिंग सिस्टम होगा। सिमिलरली हम थर्ड कंटेनर जो देख रहे हैं उसके अंदर अल्पाइन ऑपरेटिंग सिस्टम और स्टैटिक लाइब्रेरी दे दी गई। मतलब अगर हम एक समरी में शॉर्ट फॉर्म में कहना चाहें तो कंटेनर के अंदर आपका यूज करने वाला ऐप और उससे रिलेटेड लाइब्रेरीज उसमें दे दी जाती हैं और उस कंटेनर को आप अपने सिस्टम पर रन करके यूज कर सकते हो। अब आपके दिमाग में अभी क्वेश्चन ये आ रहा होगा कि व्हाई वी यूज द कंटेनर बट वी वेदर वी हैव द वर्चुअल मशीन। जब वर्चुअल मशीन हमारे पास है तो हम कंटेनर का क्यों यूज करें? तो इसका आंसर ये है कि वर्चुअल मशीन में आप सारे रिसोर्सेज, सिस्टम के रिसोर्स, जिसको मैं बोलूं प्राइमरी मेमोरी, सेकेंडरी मेमोरी, सीपीयू, आप उसको पहले रिजर्व कर लेते हो, लेकिन कंटेनर में आपकी जितनी डिमांड होती है उतने ही रिसोर्स को आप कंज्यूम करते हो, अननेसेसरी कंजम्पशन नहीं करते हो। दैट मींस लिंक लिस्ट की तरह कि हमारी जितनी रिक्वायरमेंट है स्टोरेज की, हम उतने ही स्टोरेज को अलॉट करके उसमें नोड क्रिएट कर देंगे, जितनी हमको जरूरत नहीं है हम उसको फ्री करते जाएंगे, राइट। तो सेम एज इट इज कंटेनर में होता है। कंटेनर में जितनी आपको रिसोर्सेज की जरूरत होगी उतनी आप अलॉट करा लोगे और उसको फिर यूज करोगे। जब वो कंटेनर रन करेगा तो वो इजिली रन कर जाएगा। क्यों? क्योंकि कंटेनर के अंदर ऐप और उससे रिलेटेड सपोर्टेड लाइब्रेरीज आपको उसमें दे दी गई होंगी। सो कंटेनर अगर हम एक शॉर्ट फॉर्म में अगर सिंपल सिंपल लाइंस में अगर अंडरस्टैंड करने की कोशिश करें, सो कंटेनर इज बेसिकली स्टैंडर्डाइज्ड पैकेजिंग ऑफ सॉफ्टवेयर एंड डिपेंडेंसीज। मेक इट क्लियर, आप जो सॉफ्टवेयर बना रहे हो, सॉफ्टवेयर को बनाने के लिए जितनी भी डिपेंडेंसीज है वो सारी चीजें एक साथ बाइंड करके रखी जाती हैं। आइसोलेट एप्स फ्रॉम ईच अदर। जब आप एक कंटेनर और 2 कंटेनर को एक साथ रन करते हो तो दोनों कंटेनर आपस में आइसोलेटेड रहते हैं, मतलब एक ऐप दूसरे के में इंटरफेरेंस नहीं कर सकती। दे शेयर द सेम ऑपरेटिंग सिस्टम कर्नल। जो आप डॉकर के जब यूज करते हो तो पर्टिकुलरली वो होस्ट ऑपरेटिंग सिस्टम का कर्नल यूज करता है। कर्नल जैसे कि आप जानते ही होंगे, आप लोगों ने पढ़ा भी होगा कि कर्नल बेसिकली आपके हार्डवेयर और आपके ऑपरेटिंग सिस्टम के बीच की लेयर होती है, राइट। जब ऑपरेटिंग सिस्टम कुछ भी इशू करता है तो वो कर्नल के पास ही जाता है। कर्नल के अंदर आपकी HAL लेयर होती है जिसको बोलते हैं हार्डवेयर एब्स्ट्रैक्शन लेयर, जो कि डायरेक्टली आपके हार्डवेयर से इंटरेक्ट करती है और जो भी रिस्पॉन्स आता है उसी HAL लेयर से होते हुए, कर्नल से होते हुए ऑपरेटिंग सिस्टम से यूजर के पास प्रोवाइड की जाती है। तो जितना भी आपका इंटरेक्शन कंटेनर का चल रहा है वो डायरेक्टली OS के कर्नल के ऊपर वर्क करता है। वर्क्स फॉर ऑल मेजर लाइनक्स डिस्ट्रीब्यूशन। लाइनक्स की जितने भी वर्जन मार्केट में अवेलेबल है उसमें आपका डॉकर इजीली वर्क कर सकता है। कंटेनर्स नेट टू विंडोज सर्वर 2016। सो विंडोज में अगर आपको यूज करना है तो उसके लिए बेसिकली आपको डॉकर का टूल बॉक्स एज वेल एज आपको एक वर्चुअल बॉक्स को डाउनलोड करना पड़ेगा। दोनों फ्री ऑफ कॉस्ट, उसको डाउनलोड करने के लिए कोई चार्जेस नहीं। वर्चुअल बॉक्स ऑरेकल के द्वारा फ्री ऑफ कॉस्ट प्रोवाइड किया जाता है और जो सपोर्टिंग जो टूल बॉक्स है वो भी आपको फ्रीली नेट पे अवेलेबल होता है। ये दोनों चीज आपको गिटहब में मिल जाएगी। गिटहब जैसे कि आप जानते हैं कि बिगेस्ट रिपोजिटरी है जिसमें हमारे पास सारे कोड्स, जो इंजीनियर्स और रिसर्चर्स होते हैं वो अपने कोड उसमें या अपने सिमुलेशन के कोड रखते हैं, तो सेम आपको ऑरेकल टूल बॉक्स का भी कोड उसमें अवेलेबल हो जाएगा। Now, you can run several microservices in the same virtual machine by using various Docker containers for each microservice. जैसे मैंने आपको बताया कि पहले जब माइक्रोसर्विस को हमको इंप्लीमेंट करना होता था तो उसके लिए हमें वर्चुअल मशीन क्रिएट करनी पड़ती थी जो रिसोर्स को अलॉट कर लेती थी, भले उसको फुल्ली यूटिलाइज करें ना। लेकिन डॉकर में ये चीज का फायदा है, डॉकर में हमको जितनी डिमांड होगी उतनी ही हम डिमांड के रिसोर्स को अलॉट करवाएंगे, उसको यूज करेंगे, उसके बाद उसको फ्री कर देंगे। तो कहीं ना कहीं जब माइक्रो सर्विस को इंप्लीमेंट करने की बात आई तो वर्चुअल मशीन की जगह डॉकर का ही यूज किया गया, पहली चीज। और दूसरा, इसको इसलिए भी यूज किया जाता है क्योंकि डॉकर में जितनी माइक्रो सर्विस होती है वो कहीं ना कहीं इंडिपेंडेंट वर्क करती हैं, और उनको इंडिपेंडेंट वर्क करने के लिए उनकी लाइब्रेरीज, उनके सपोर्टिंग डीएलएल फाइल्स, वो सब कहीं ना कहीं डॉकर इमेज में हम एम्बेड करके एक साथ रख सकते हैं। तो ये दो रीजन के कारण ही कहीं ना कहीं माइक्रो सर्विस को इंप्लीमेंट करने के लिए डॉकर का यूज किया गया। Right now, next point is it provides a consistent computing environment throughout the whole SDLC. That was a software development life cycle. जब हम कोई सॉफ्टवेयर डेवलप करते हैं तो उसके लिए हम अलग अलग लाइफ साइकिल्स को फॉलो करते हैं. वी कैन फॉलो द वाटरफॉल मॉडल, वी कैन फॉलो द स्पाइरल मॉडल, वी कैन फॉलो द इंक्रीमेंट मॉडल, वी कैन फॉलो द डिफरेंट मॉडल्स. तो अलग अलग मॉडल्स अगर हम यूज करते हैं डेवलपमेंट करने के लिए, तो उसमें कहीं ना कहीं डॉकर आपको एक कंफर्टेबिलिटी जोन प्रोवाइड करता है. नाउ एक सिंपल सा एक व्यू देखें. जैसे मैंने आपको बताया कि डॉकर जो होता है वो होस्ट ऑपरेटिंग सिस्टम के कर्नल पे डायरेक्टली वर्क करता है. इसका एक डायग्राम आपको शॉर्ट सा दिया गया है. देखिए आपने कंटेनर दो बनाए हैं, दो कंटेनर आपके रन कर रहे हैं जिसके अंदर अलग अलग ऐप है और उनके सपोर्टेड उसमें लाइब्रेरीज है, राइट. और ये कहीं ना कहीं डॉकर इंजन आपके होस्ट ऑपरेटिंग सिस्टम में वर्क कर रहा है, राइट. सो डॉकर इज अ टूल, इट इज अ टूल डेफिनेटली. इट प्रोवाइड्स यू, इट प्रोवाइड्स यू a power to create, to deploy and run the applications by using container. आज की तारीख में मेजॉरिटी ऑफ टेक्नोलॉजीज और इंडस्ट्रीज कहीं ना कहीं डॉकर का यूज करके ही इंप्लीमेंटेशन कर रही है. सो डॉकर एक टूल है जिससे ऐप को बनाना बड़ा आसान हो गया है, डिप्लॉय करना आसान हो गया है, उसको हम इजीली मैनेज भी कर सकते हैं. दैट्स व्हाई डॉकर का यूज किया जाता है. डॉकर कंटेनर्स आर लाइट वेट. व्हाई? बिकॉज जितनी रिक्वायरमेंट होती है उतनी ही हम सिस्टम के रिसोर्स का कंजम्पशन करते हैं. अल्टरनेटिव टू वर्चुअल मशीन्स, एंड इट यूजेस द होस्ट ऑपरेटिंग सिस्टम. You do not have to pre-allocate any RAMs in container. ये सबसे बड़ा एडवांटेजेस पॉइंट है. वर्चुअल मशीन जब आप क्रिएट करते हो तो उसमें रिसोर्सेस इंस्टॉल, मतलब कोई गेस्ट ऑपरेटिंग सिस्टम इंस्टॉल करने से पहले ही सारे रिसोर्स को आपको सेट करना पड़ता है. नो डाउट आप उसको बाद में भी मॉडिफाई कर सकते हो, लेकिन एक एग्जीक्यूशन गेस्ट ऑपरेटिंग सिस्टम में जब वो रन कर रहा होगा उसमें अगर आप कहें कि हम उसके हार्डवेयर को चेंज करें तो दैट वाजंट प्रॉब्लमेटिक. सो ये कहीं ना कहीं ये जो सिस्टम के इफिशिएंट यूटिलाइजेशन अगर करना होता है तो कहीं ना कहीं डॉकर उसमें बहुत एडवांटेजेस होता है. सो डॉकर ने कहीं ना कहीं जो इंप्लीमेंटेशन के पॉइंट ऑफ व्यू से जब हम माइक्रो सर्विस को इंप्लीमेंट करते हैं तो उसकी इंप्लीमेंटेशन की जो सिस्टम के रिसोर्सेज का अगर इफिशिएंटली यूटिलाइजेशन करना होता है तो उसमें हम लोग डॉकर का यूज करते हैं. नाउ अब डॉकर वर्क कैसे करता है? मैंने आपसे कहा कि इमेज होती है जो एक बीज की तरह होती है, उसका एक डॉकर का कंटेनर होता है जो एक पेड़ का रूप ले लेता है. लेकिन ये कैसे पॉसिबल है, उसका फ्लो चार्ट क्या है? तो आप जैसे डायग्राम में देख रहे होंगे, डॉकर फाइल सबसे पहले स्टार्टअप होती है. डॉकर फाइल जो होती है वो डेवलपर के द्वारा बनाई जाती है, वो जिसे आप बनाते हो. लेट मी शो यू द एग्जांपल. आप यहाँ पर एग्जांपल देख रहे होंगे, ये एक डॉकर की फाइल है जो कि एक डेवलपर क्रिएट करता है. मैं लास्ट स्लाइड में इसलिए लाया क्योंकि इसे कमांड्स की बात बताना था, लेकिन एक एग्जांपल बताने के लिए कि डॉकर फाइल होती कैसे, कैसे क्रिएट की जाती है. तो इसे डेवलपर क्रिएट करता है. ये डॉकर फाइल कहीं ना कहीं आगे जाके आपके डॉकर का इमेज का रूप लेती है. डॉकर इमेज क्या होती है? आपने फाइल के अंदर सारी कोडिंग कर दी, फिर उसकी एक इमेज क्रिएट होती है. इमेज मतलब उसके अंदर ऐप होगा, उससे सपोर्टेड लाइब्रेरीज होंगी, वो सारी चीजें एक इमेज का रूप लेकर के रख दी जाएंगी. उसके बाद उस इमेज को हम डॉकर हब में डालते हैं. डॉकर हब एक क्लाउड है, डॉकर के द्वारा प्रोवाइड करा क्लाउड का कंटेनर है जिसके अंदर अलग अलग तरीके की इमेजेस अवेलेबल हैं और आप उनमें से किसी भी इमेज को, पब्लिकली इमेज को इजीली अवेलेबल यूज कर सकते हो. मतलब जो डॉकर हब है उसमें दो तरीके की जोन है, एक है प्राइवेट जोन, एक है पब्लिक जोन. प्राइवेट जो पब्लिक जोन है उसके अंदर बहुत सारी इमेजेस अवेलेबल है पब्लिकली जिसका आप जब चाहे यूज कर सकते हो, लेकिन प्राइवेट वाली आप उसे यूज नहीं कर सकते. उसके लिए आपको ऑथराइजेशन, ऑथेंटिकेशन को फेस को पास करना पड़ेगा, राइट. सो आपने एक डॉकर फाइल या डेवलपर ने एक डॉकर फाइल बनाई, उससे एक इमेज क्रिएट हुई, उस इमेज को हमने डॉकर हब में डाल दिया. अब मुझे जब भी उस इमेज को या उस कंटेनर को रन करना होगा तो मैं उस इमेज को डॉकर हब से उठाऊंगा और अपने सिस्टम पे लेके आऊंगा, उसको इंस्टॉल कर दूंगा और मेरा ऑपरेटिंग सिस्टम जो भी मैं यूज करना चाहता हूं वो एज इट इज वर्क करेगा जैसे वर्चुअल मशीन में वर्क करता है. तो ये फ्लो चार्ट है, किस तरीके से आपने कोडिंग करी, उसकी इमेज बनी, फिर वो डॉकर हब जो कि क्लाउड का स्टोरेज है उसके अंदर वो स्टोर हुआ, उसके बाद क्लाइंट ने जब चाहा उसे पुल करके उसको यूज कर लिया. So Docker file builds a Docker image and that image contains all the project code. जैसे मैंने आपको बताया कि Docker फाइल के अंदर वो सारी कोडिंग होती है जिससे Docker image क्रिएट होती है. You can run that image to create as many Docker containers as you want. मतलब अगर आप चाहें तो अपने सिस्टम पे उसी इमेज को बार बार पुल करके एक अलग अलग वर्जन क्रिएट कर सकते हो. Then this image can be uploaded on the Docker Hub. Docker Hub मैंने आपको बताया कि क्लाउड स्टोरेज है जिसमें आपकी वो इमेज रख दी जाती है और जब आपको यूज करना होता है आप उसे पुल करके उसे यूज करते हो. From Docker Hub, can anyone can pull the image and build a container. Docker Hub से कोई भी इमेज को डाउनलोड करके हम अपना कंटेनर बना के उसमें कुछ और मॉडिफिकेशन करके भी एक नई इमेज बना सकते हैं जिसे हम फिर फ्यूचर में फिर से हब में स्टोर कर सकते हैं. Now, some of the vocabulary of the Docker. So, Docker image, the basics of Docker container represents a full application. जब भी आपसे कोई Docker की बात करता है या आप नेट पे अगर Docker की बात करते हो तो Docker एक इंडिपेंडेंट नहीं है. Docker के अंदर बहुत सारी चीजें होती हैं. Docker client, Docker server. जैसे जब आप Docker आप अपने सिस्टम में इंस्टॉल करोगे, एट दैट टाइम आप कोई भी रिक्वेस्ट अगर Docker को देते हो, दैट मीन्स यू आर गिविंग द रिक्वेस्ट टू द क्लाइंट एंड दैट रिक्वेस्ट इज गोन टू द सर्वर. Docker सर्वर जो आपके सिस्टम में इंस्टॉल होता है, वो सर्वर से रिक्वेस्ट करता है कि यूजर ने फला फला ऑपरेटिंग सिस्टम को या पर्टिकुलरली इस इमेज को पुल करने के लिए कहा. अगर वो इमेज लोकली अवेलेबल होती है तो वो आपके सिस्टम में ऑन हो जाती है. अदरवाइज उसे डॉकर हब से डाउनलोड किया जाता है, पुल किया जाता है और आपके सिस्टम में ऑन किया जाता है. तो जब भी डॉकर की आप बात करते हो तो दैट मींस उसमें डॉकर क्लाइंट, डॉकर हब, डॉकर कंटेनर, ये सारी चीजें टर्म्स उसमें इन्वॉल्व होगी. नाउ फर्स्ट, जैसे कि हमने देखा था डॉकर हब क्या होता है, दैट इज द बेसिक ऑफ द डॉकर कंटेनर रिप्रेजेंट्स अ फुल एप्लीकेशन. एक डॉकर इमेज के अंदर एप्लीकेशन, उससे सपोर्टेड लाइब्रेरी, सब कुछ उसके अंदर होता है. Second, Docker container, the standard unit in which the application server resides and execute. Container वो जोन होता है जिसमें आपका एप्लीकेशन रन करता है और आपको आउटपुट देता है. Docker engine, it creates, ships and runs Docker containers deployable on a physical or virtual host locally in a data center or cloud service provider. Docker engine वो इंजन होता है जिसके अंदर आपका वो पार्ट पूरा जो कंटेनर है वो एग्जीक्यूट करता है. एंड द लास्ट इज द रजिस्ट्री सर्विस, डॉकर हब, जो कि क्लाउड स्टोरेज होता है जिसमें आपकी सारी इमेजेस को पुल कर दिया जाता है और जरूरत पड़ने पे उसे हम मतलब स्टोर किया जाता है और जरूरत पड़ने पर हम उसे पुल करते हैं. So Docker registry is the storage component for Docker image. We can store the image in either public or private repositories. इसमें दो तरीके की रिपोजिटरी होती है, जैसे कि मैंने आपको बताया. जो पब्लिक रिपोजिटरीज होती हैं उसके अंदर इमेजेस को हम कभी भी एक्सेस कर सकते हो. जो प्राइवेट रिपोजिटरीज होती हैं उसमें हमारे पास ऑथेंटिकेशन होना चाहिए जिससे हम एक्सेस कर पाए. डॉकर हब इज डॉकर्स वेरी ओन क्लाउड रिपोजिटरी. एज इट इज मैंने कहा कि क्लाउड डॉकर हब उसका स्टोरेज जोन है जिसमें हम पर्टिकुलरली उसकी सारी इमेजेस स्टोर करते हैं. So due to short span of time, I'm covering the faster topics. So this is a small snapshot of the Docker Hub online. ये ऑनलाइन है जिसमें आप अपनी इमेज को एक्सप्लोर कर सकते हो, मतलब कोई भी आप इमेज एक्सप्लोर कर सकते हो, अपनी रिपोजिटरीज क्रिएट कर सकते हो, अपनी रिपोजिटरीज में सेव कर सकते हो. सो पर्टिकुलरली ये एक ऑनलाइन जोन है hub.docker.com. इस पे आप जा करके रिपोजिटरीज को एक्सप्लोर कर सकते हो, इवन अपनी रिपोजिटरी क्रिएट भी कर सकते हो. डॉकर ऑनलाइन भी अवेलेबल है. आपको ऑनलाइन 3 घंटे का जोन प्रोवाइड करता है जिसमें आपको कुछ इंस्टॉल नहीं करना है. ऑनलाइन आप उसमें सारे कमांड्स को पुल पुश सब कुछ कर सकते हो. लेकिन अगर आपको प्रैक्टिस करना है, माइक्रो सर्विस को इंप्लीमेंट करना है, देन इट इज बेटर टू इंस्टॉल द डॉकर इन योर सिस्टम. So Docker image, it is only a read-only image used to create containers built by Docker users stored in the Docker Hub or your local registry. Docker container, it is an isolated application platforms. It contains everything needed to run the application. जैसे कि मैंने आपको बताया कि एक एप्लीकेशन को रन करने के लिए उसकी supported libraries, everything is available in the container, and you can just simply run it and use see the output. Built from one or more images, it container can be built or by using the 2 or 3 images. It is also possible. Now, the next term is the Docker Compose. It is always required that we have to merge 2 or 3 containers all together. जैसे कि माइक्रो सर्विस की ही हम बात करें, जब भी अगर हमको कुछ आउटपुट चाहिए तो इट इज रिक्वायर्ड टू मर्ज 2 or 3 माइक्रो सर्विस ऑल टुगेदर. कभी कभी ऐसी रिक्वायरमेंट होती है. एट दैट टाइम वी आर यूजिंग द डॉकर कंपोज. सो डॉकर कंपोज मेक इट इजियर टू कॉन्फ़िगर एंड रन एप्लीकेशंस मेड अप ऑफ मल्टीपल कंटेनर्स. मेक द नोट ऑफ दिस पॉइंट, वी आर यूजिंग मल्टीपल कंटेनर्स. तो जब हम मल्टीपल कंटेनर्स, दैट मींस मल्टीपल माइक्रो सर्विस को एक साथ मर्ज करके यूज करना चाहते हैं, देन एट दैट टाइम वी आर यूजिंग Docker Compose. For example, imagine being able to define 3 containers, one running a web app, एक कंटेनर है जो कि वेब ऐप को रन कर रहा है, another running Postgres. This is a database which is specifically designed to work in the real time environment. रियल टाइम सिस्टम वो डिफरेंट कहानी है, मैं वहां तक नहीं जाऊंगा, लेकिन पोस्टग्रेस एक डेटाबेस है जो स्पेसिफिकली रेप्लिकेशन और रियल टाइम के लिए यूज किया जाता है. एंड थर्ड इज द रेडिस. सो ये 3 कंटेनर्स को हम एक साथ यूज करना चाहते हैं या एक साथ इनिशिएट करना चाहते हैं, तो ऐसे टाइम पे हम डॉकर कंपोज का यूज कर सकते हैं. अगर आप ऐसा करना चाहते हो तो एट दैट टाइम यू हैव टू क्रिएट वन YML फाइल दैट इंक्लूड्स ऑल द कंटेनर इनिशियलाइजेशन पैरामीटर्स. मतलब आप YML फाइल में सबको डाल दीजिए और उसके बाद उस YML की फाइल के थ्रू उस सारे कंटेनर्स को एक साथ एग्जीक्यूट कर सकते हैं. इमेजिन करिए कि आपका माइक्रो सर्विस है जिसमें वेब ऐप में आपका सर्वर चल रहा है, पोस्टग्रेस में आपका डेटाबेस चल रहा है, रेडिस में आपका ऑपरेटिंग सिस्टम चल रहा है. मैं चाहता हूं कि तीनों एक साथ इनिशिएट हो, तो एट दैट टाइम you have to use the Docker Compose. Now the multi-container applications. So here is a simple example. build and run one container at a time, manually connect containers all together, ये connect करने का तरीका है. Must be careful with dependency and startup order. ये भी बहुत इंपॉर्टेंट होता है कि जब कंटेनर्स को आप मर्ज करके चलाते हो तो कौन सा कंटेनर कैसे रन करेगा और किसकी डिपेंडेंसीज किसी में इंटरफेयर ना करे, ये भी बहुत इंपॉर्टेंट होता है. सो डिफाइन मल्टी कंटेनर एप्स इन compose.yml फाइल. इसका एक एग्जांपल हम देखते हैं. ये आपको एग्जांपल दिखाई दे रहा होगा. ये देखिए yml फाइल है जिसमें हमने अलग अलग कंटेनर्स को एक साथ मर्ज कर दिया और हम सारे कंटेनर्स को एक साथ इसी yml के फाइल के थ्रू एग्जीक्यूट करके उसका रिस्पॉन्स देख सकते हैं. सो माइक्रो सर्विस में इसका बहुत इंपॉर्टेंट रोल होता है क्योंकि माइक्रो सर्विस में एक सर्विस का ही आउटपुट नहीं है, हमारे पास एक से ज्यादा सर्विस होती है और उन्हें हमें यूज करना पड़ता है हमारी कंडीशन के हिसाब से. फॉर एग्जांपल मैं रेलवे की बात करता हूं कि एट अ टाइम ट्रेन का डेटाबेस भी चेक होगा, एट अ टाइम कस्टमर का भी क्या कहते हैं यूजर का भी डेटाबेस चेक होगा. तो एट दैट टाइम सम इट इज रिक्वायर्ड वी हैव टू यूज द 2 or 3 माइक्रो सर्विस ऑल टुगेदर. एट दैट टाइम यू हैव टू यूज दिस YML file. Now I'm giving the simple examples or simple commands which can be used for the Docker. First is the Docker pull. That is the most important command which every user have to learn, right? This pull is a command which is used to pull the image from the Docker hub and to run that image in our system, that run that container in our system. Image ls, that is known by all the Linux user. This is a list command. Similarly, we have the container ps command, container run command, container stop command, container remove command, creating image command, build command. -t stands for the terminal. Image push, जो आपने नई इमेज बनाई उसको पुश करना हो, तो ये सारी कमांड्स है जिसका हम मेजर ऑफ टाइम्स यूज करते हैं, जिसमें फर्स्ट कमांड का मेजॉरिटी टाइम यूज करते हैं जिसको हम पुल कहते हैं. क्योंकि हम जब फर्स्ट टाइम लर्न करते हैं, आप भी फर्स्ट टाइम जब इंप्लीमेंटेशन करेंगे तो मैक्सिमम टाइम पुल ही करेंगे. उसके बाद में इमेज बनाएंगे, नोड जीएस के साथ कनेक्ट करेंगे, उसकी इमेज बना करके उसको कंटेनर बना के उसको पुल कर देंगे, पुश कर देंगे, ये वगैरह वगैरह बात की चीजें, लेकिन पहले पुल का ही हम यूज करेंगे. So this is a simple example of the Linux. Here you are seeing Docker file जिसके अंदर हमने बकायदा कैसे Docker file बनती है, उसकी इमेज कैसे क्रिएट होगी, ये देखिए. Create image based on the official पूरा डिस्क्रिप्शन दिया है. Run the make directory command, use the apps, create the package.json file, install the npm, that was an npm tools and expose for user to. तो इस तरीके से हम पूरी डॉकर फाइल क्रिएट करते हैं और इस डॉकर फाइल को कहीं ना कहीं हम रन करके उसका आउटपुट देखते हैं. Similarly, one more example of this creating the Docker file. So these are the files which are created by the developer as well as it is created by you also to create the image, and that image can be can be stored on the cloud storage, that was Docker Hub, and it can be pulled by any user at a time to run on the operating system. So Docker का बहुत advantages है. Docker का यूज आज की तारीख में मेजॉरिटी ऑफ इंडस्ट्री यूज करी क्योंकि कहीं ना कहीं ये सिस्टम के रिसोर्स का efficiently यूटिलाइजेशन करता है, right? So these are the basics commands and these are the basics instructions of the Docker file. So this is part from the my side, and the remaining part will be covered by Dr. Vineet sir. So Rawat sir.
Thank you, Pratik sir, for giving a clear description on Docker and how it is different from virtual machine, and a sort of commands that are I think helpful and helpful for the students that want to learn Docker. Now I welcome Dr. Vinesh Kumar to carry forward the session.
Thank you, Mukesh sir, for giving me the opportunity to explain my part. Let me share my screen first. My topic is Kubernetes, and this is Dr. Vinesh Kumar going to explain this Kubernetes topic. And thank you, Dr. Pratik Srivastava, to explain Docker and container in such a way that everyone can understand what is a container and how this works. Because the work of Kubernetes start after the Docker container. So to enhance the working of container, the Kubernetes came into existence. So in these slides, we will go through these contents, that what is the need of Kubernetes, what is Kubernetes, what are the components, and how the API of Kubernetes works, and understand the Kubernetes object and what is pod in Kubernetes. Now we know that how the container works. Container is a wonderful thing to create the microservice or to manage the microservice. But we know that the most of the microservice development are based on container because they have a very strong capability that container are fast, container are reliable, container are efficient, then and lightweight and scalable, but they are not auto scalable. They have a problem. There is a problem with the containers that can be enhanced by the Kubernetes. So let us understand what are the what is the need of Kubernetes. What are the problem with containers? So for first, the thing that container work on the software layer. They do not interact with the hardware. So the platform as a service is not provided by the container. These are the software package or software services that is done for the for applications. They not easily scalable. How we can say not easily scalable? For example, we are having a ecom app. If my ecom app is having several modules like sales modules, when a season comes, a festival season comes, my app is having a lots of sales module. Then when the traffic increases in my module, that is sales module, then my system must enable more and more containers so that the sales module can handle the several requests. This is called the auto scaling, in which we can contribute or we can scale up more and more containers to handle the more and more sales request. So this facility is not provided by the container. No auto scaling is possible there. The next problem with the container, that load balancing problem, means if in between my host reboots or my application is killed by some traps or some error, so there is no reboot concept in the container. Or another example, suppose if I am giving some services that if my CPU uses increases by a threshold value, then my load must be balanced. So still there is no some such kind of facility that if a load increases, then the lost load can be distributed to another host. So this facility is not provided in the container. The both Linux and Docker container isolate the application from the host. They are not part of the hardware or they are not part of the operating system. So let's continue one more problem with the container, that when we are going to scale up the container, we are going to throwing more and more container into the system. That what problem arises when we want to grow our number of container in the system, because there may be need of throwing more and more container to handle up the request of the clients. The problem with container that they do not communicate with each other. For example, if the traffic is increasing on my app, so then they do not communicate each other. Or if they can communicate, they can scale up the number of containers into the system. So, for example, let's take a one scenario. Suppose we want to increase the number of container in case of CPU utilization increases by a threshold value. For example, 60%. If my CPU is using 60% of resources, then there must be some kind of auto scaling is there or load balancing must be there. Then it cannot be possible by the container system. Number two, distributed traffic lane means my if my app is working in a different country, like in Australia, like America, like India, and my app is hosted on the server in different server or different countries, then if in some area if traffic increases, then load must be distributed to another host or another server so that the traffic can be handled. So this problem is also there with the containers. Now, what is the need? If there are problem with the containers, so what we can do to improve the functionality of the containers? Because Kubernetes is not the replacement of container, it is to increase the functionality of the container. Because container is an orchestration solution. What do you mean by orchestration solution? That how can make a container highly available? For example, if a container, my app's going to down time and time, if traffic increases, and there is a lots of loads on server, if traffic increases, so the Kubernetes provided the services so that my app will be available to everyone in case of highly loads or highly scalability. Auto scaling facility can be provided by the Kubernetes system so that a number of container can be increased by doing scaling of the system. Load balancing problem can be solved. Suppose if CPU utilization increases or load is server is overloaded, then this facility, this Kubernetes facility, decrease the load by uh, transferring the load to the next server or next service. So all these problems can be solved by the Kubernetes. Now we can define the Kubernetes. What is the Kubernetes? The Kubernetes is a portable, or we can say portable means we can transfer one platform to another platform the services. Extensible, we can increase the functionality. Open source platform for the managing the containerized workload and services. If they are container based solution are there, Docker is there, then Kubernetes provide the environment that these functions of the Docker can be increased here, that facilitate both declarative configuration and automation of the system. The Kubernetes had the large rapidly growing ecosystem. Kubernetes services support and tools are widely available because it has a large community support. Kubernetes has a large community support. Now we talk what Kubernetes language. The Kubernetes is written in Go language, and it is developed by the Google. Now nowadays it has a large community support, and the architecture of Kubernetes is based on the client server based, like a client server architectures. Now we will understand why we need the Kubernetes and what it can do. What are the advantages of this Kubernetes technology or services? The first feature of this Kubernetes is automatic bin packing. Automatic bin packing means, for example, if my apps are installed on a Linux virtual machine based on some container technology, then if my app or my container want to allocate some resources of the virtual machine, then there must be some automatic calculation of resources and automatic uh, capturing the resources of the system. Then this Kubernetes provide the concept in which my container can take the resources automatically and can release their resources after using. This is called automatic bin packing feature. The next feature of Kubernetes is discovery, service discovery, and load balancing. So for example, if we want to increase the some kind of service of my through my apps, or we can want a new kind of module to our container that we can do with the Kubernetes. Or load balancing is there. Suppose my server is taking the more and more loads, then some load can be distributed to another kind of server or next server in a maximum distributed geographical area. And it is a storage orchestration. It means the Kubernetes gives the platform in which we can deploy, we can manage our containers, we can deploy our containers, we can distribute our containers, or we can scale up the containers, we can do auto load balancing through there. For example, if we are having several kind of version of my app, like version 1, version 2, version 3, version 4, and after time, if I realize that version 1 is needed again, so it is the capability of Kubernetes that after version 4, I can deploy the version 1, or I can replace any version. That is the capability of my Kubernetes. Now, next feature says automated rollouts and rollbacks. For example, rollbacks means suppose if my apps is not working, my e-com apps or any other apps or my game apps is not working well, then I can roll back a container, or I can roll out a new container into my services or my applications. So this is the again feature. Then a self-healing feature is there because it works on the master and slave architecture. If one server is not working well, then the load can be transferred to another server, or this feature is called self-healing feature of this. Then the security feature is there, or secret, we say secret and configuration management is there. There is an inbuilt mechanism to maintain the security of a app. Like if we talk about the AWS, Amazon Web Service, there is a AWS secret manager is there, or if any kind of cloud service is there, uh, Google Cloud can be there. So there a secret manager or security manager is a component of every uh, cloud services. So security features is there in Kubernetes system. One more thing, we will talk that Kubernetes is not a Docker. It is not a replacement of Docker, but it can enhance the capability of Docker. For example, Kubernetes is not a traditional platform as a service, because in Google platform environment, Google service platform as a service can be there, but Kubernetes is not a platform as a service because it is a part of software layer. It is not part of a hardware layer, or it is not a part of kernel. Then Kubernetes operates at the container level rather than the hardware level. So it provides some generally application feature common to platform as a service, such as a deployment, such as a scaling, such as a load balancing, and lets the user integrate their logging monitoring, their alerting solution is there. If something is we are want to alert by apps, then Kubernetes is not a monolithic. Then these default solutions are optional and pluggable. So it does not work on the monolithic approach. Then Kubernetes provide the building block of a building developing platform, and but it's preserve the user choice and flexibility where it is important. Then what are the limitation or disadvantage of this Kubernetes system? It does not limit the type of application supported. So there can be a limitation. There must be a limitation defined to type of application. So Kubernetes aims to support an extremely diverse variety of workloads, including stateless, including stateful, and data processing workload. So if an application can run any container, it should be run great on Kubernetes. Means uh, there are several kind of several kind of cloud services there. Google Cloud is there, AWS is there, and other cloud services are. Kubernetes can work with the all, but it cannot the limit the all type of applications. So next disadvantage, it does not deploy the source code and does not build your application. Continuous integration, delivery, and deployment workflow are determined by the organization, culture, and preference, as well as the technical requirements. Next, it does not dictate logging file, the monitoring, the alerting solution. It provides some integration as a proof of concept and mechanism to collect the export metrics. It does not provide any mandate or a configuration language or system. It provides a declarative API that may be targeted by the arbitrary forms or declarative specification. It does not provide, adopt any comprehensive machine configuration. It maintenance, management, and self-healing system. Now, let's talk about the Kubernetes architecture cluster. Kubernetes work on the client server architecture where there is a Kubernetes master is there, and this master is having the user interface and API and CLI is there, and these API are based on the Docker system, and these Kubernetes master communicate with the clients, those called node 1, up to node n, or these node are having a collection of pods. That is basically a pod is a basically a working unit of this Kubernetes architecture. I will explain in the next slide. Now, let's understand what are the objects in Kubernetes. For example, a master. What is a master object? That is a written in JSON or YML language. API interact with a node of the like client system. And Kubernetes objects are very persistent. Entitled in the Kubernetes system, Kubernetes uses these entities to represent the state of your cluster. Container reside in the pods. The pods is the unit of Kubernetes. Container share IP address of the pod, because our Kubernetes, our pod, the container that does not have any IP address because they share the IP address of the pod. Generally, one container, one pod is, architecture is there, but it may be possible that uh, a pod can have a multiple container. Now, what are the pods? Let me define what the pods. Pods are the smallest deployable unit of the computing that you can work with in the Kubernetes. A pod is a group of one or more containers, we can say, with shared storage or network resources and specification to follow to run the containers. The pod content are always co-located and co-scheduled and run in the shared context. A pod models an application-specific logical host. It contains one or more application container which are relatively tightly coupled, and in non-cloud context, application execute on the same physical or virtual machine are analogous to cloud application or execute on the same local host. Now, the shared tech context of the pod is a set of Linux namespace, C groups, potentially, and other facets of isolation. That's the same thing that isolate a Docker container. Within the pod's context, the individual application may have the further isolation. The term Docker concept, a pod is similar to the group of Docker containers. We can say that in Docker, in the we see, compare the Docker concept, a pod is similar to a group of Docker containers with shared namespace and shared file system volumes. Now, how we can use pods? The pods, we can use pods in two ways. Usually, we don't need to create the pod directly, even a singleton pod. Instead of create them, we use the workload resources such as the deployment or job. We we will talk about the how we can use the pods in Kubernetes. That pods can run as single container. It means one container per pod. One pod is there and one container is there. This model is mostly common in Kubernetes use cases. And in this case, you can think of a pod as a wrapper around as a single container. Kubernetes manage pods rather than the managing containers directly. The next, when we have a multiple container, the pod that run multiple container that need to work together. A pod can encapsulate an application composed of multiple co-located containers that are tightly coupled and need to share the resources. These co-located container form a single cohesive unit of service. For example, one container serving data stored in a shared volume to the public, while a separate sidecar container refresh the updates those files. The pod wraps these container storage resources and the ephemeral network identity together. So, how ports manage the multiple container? Ports are designed to support multiple cooperating process as a containers that form a cohesive unit of service. The containers in a pod are automatically located and co-scheduled on a same physical virtual machine in the cluster. The container can share resources and the dependency, communicate with one another, and coordinate when how they terminate. Now we can say that we can rarely create individual ports directly in Kubernetes, even a singleton port. This is because ports are designed as a relatively ephemeral and disposable entity. When a port gets created directly by you or some by the indirectly by some controller, the new port is scheduled to run the node, scheduled on a run on a node in your cluster. The port remains on that node until the port finishes the execution. The port object is deleted. The port is evicted for lack of resources. So the theoretical contents for this Kubernetes uh, you can find from a community support that is called kubernetes.io. You can find the theoretical support from there or documentation from there. The theoretical part is over. Thank you for giving me opportunity. My part is over theoretically.
Thank you, Vinesh sir, for giving the value and information related to Kubernetes to enhance the Docker functionality. Okay, now I am very thankful to all the speakers who will give their valuable time, giving the valuable information related to microservices to our students. Thank you for all.
Thank you, sir.
Thank.